Welcome back. I'm Muammar Lone. Throughout our journey into natural language processing, we've explored powerful technologies that are transforming how machines understand and generate human language. Today, we tackle perhaps the most crucial aspect of NLP development: ethical considerations and responsible implementation. The power of modern NLP systems brings significant responsibilities. These systems influence decisions affecting people's lives, from job applications to loan approvals, from medical diagnoses to legal proceedings. Understanding and addressing ethical challenges isn't just good practice, it's essential for building trustworthy and beneficial AI systems. How? Understanding bias in NLP. Bias in NLP systems often reflects and can amplify societal biases present in training data. Types of bias. 1. Historical bias. Gender stereotypes in occupation detection. Example: system associating doctor with male and nurse with female. Impact: reinforcing professional stereotypes. Mitigation: balanced training data and explicit debiasing. Racial bias in sentiment analysis. Example: different sentiment scores for identical text with different racial references. Impact: discriminatory content moderation. Solution: comprehensive bias testing and correction, age discrimination in automated systems. Example: resume screening favoring certain age groups. Impact: unfair hiring practices. Mitigation: age-neutral feature selection. 2. Technical bias. Dataset representation issues. Underrepresented groups in training data. Geographic bias in language models. Cultural context limitations. Socioeconomic skew. Algorithm design choices. Feature selection bias. Model architecture limitations. Optimization metric bias. Threshold setting impacts. Case study. Resume screening system. Problem identification. Gender bias in candidate selection. Word choice associations. Career gap penalties. Leadership description bias. Recommendation letter patterns. Industry experience, favoritism. Company name bias. Role title preferences. Industry jargon impact. Career path assumptions. Solution. Implementation. 1. Data preparation, balanced training datasets. Anonymous resume formats. Standardized terminology. Bias-aware pre-processing. 2. Model development, regular bias audits. Fairness metrics. Transparent decision paths. Multiple reviewer systems. 3. Deployment safeguards. Human oversight. Appeal processes. Regular updates. Performance monitoring. Privacy and security considerations. NLP systems often process sensitive personal information, requiring robust privacy protections. Key privacy concerns. 1. Data collection and storage. User consent management. Clear purpose specification. Opt-in, opt-out mechanisms. Data retention policies. Access controls. Data minimization principles. Essential data only. Purpose limitation. Storage optimization. Regular cleanup. 2. Model security training. Data protection. Encryption methods. Access logging. Audit trails. Breach prevention. Inference attack prevention. Model memorization checks. Output filtering. Privacy-preserving training. Security testing. Implementation guidelines. 1. Technical measures. Encryption protocols. Data in transit protection. Storage security. Key management. Access controls. Privacy-preserving training. Differential privacy. Federated learning. Secure aggregation. Anonymization techniques. 2. Organizational measures. Access control policies. Role-based access. Authentication systems. Activity monitoring. Regular audits. Incident response plans. Detection systems. Response protocols. Communication plans. Recovery procedures. SAS. Model transparency and interpretability. Understanding model decisions is crucial for trust and accountability. Transparency approaches. 1. Interpretability methods. Attention visualization. Layer-wise analysis. Decision path tracking. Feature importance. Confidence scoring. Feature attribution. LIME implementation. SHAP analysis. Gradient-based methods. Counterfactual explanations. 2. Documentation requirements. Model cards. Capabilities description. Training data sources. Performance metrics. Known limitations. Usage guidelines. Appropriate applications. Restriction notes. Best practices warning signals. Practical implementation. 1. Development phase. Architecture choices. Interpretable designs. Modular components. Logging systems. Explanation generators. Testing protocols. Behavior verification. Edge case analysis. Failure mode testing. Performance validation. 2. Deployment phase. User interfaces. Explanation displays. Confidence indicators. Decision paths. Feedback mechanisms. Monitoring systems. Performance tracking. Bias detection. Error analysis. Update triggers. Accountability framework. Establishing clear responsibility for NLP system outcomes. Organizational structure. 1. Roles and responsibilities. System owners. Decision authority. Resource allocation. Strategy setting. Performance oversight. Technical teams. Development responsibility. Maintenance duties. Update management. Issue resolution. 2. Review processes. Regular audits. Performance review. Bias checking. Privacy compliance. Security assessment. Incident response. Issue detection. Impact assessment. Mitigation steps. Communication plans. Implementation systems. 1. Monitoring infrastructure performance tracking. Metric collection. Trend analysis. Alert systems. Reporting tools. Quality assurance. Testing protocols. Validation procedures. Error detection. Improvement cycles. 2. Response protocols. Issue management. Problem classification. Priority setting. Resolution paths. Documentation requirements. Communication plans. Stakeholder notification. User updates. Regulatory reporting. Public relations. Environmental impact. Considering computational resource usage and environmental effects. Resource optimization. 1. Model efficiency. Architecture optimization. Parameter reduction. Computation efficiency. Memory optimization. Power management. Training efficiency. Resource scheduling. Parallel processing. Hardware utilization. Energy monitoring. 2. Infrastructure choices. Green computing. Renewable energy. Cooling efficiency. Hardware lifecycle. Waste reduction. Resource management. Capacity planning. Load balancing. Optimization strategies. Monitoring systems. Social impact assessment. Evaluating broader societal effects of NLP deployment. Impact areas. 1. Workforce effects. Job market changes. Skill requirements. Role evolution. Training needs. Career paths. Economic impact. Industry transformation. Productivity changes. Income effects. Market dynamics. 2. Social dynamics. Communication patterns. Language evolution. Interaction changes. Cultural effects. Social norms. Access and equality. Digital divide. Resource distribution. Opportunity access. Social mobility. Implementation guidelines. Practical steps for ethical NLP development. Development framework. 1. Planning phase. Impact assessment. Risk evaluation. Stakeholder analysis. Resource planning. Timeline development. Design decisions. Architecture choices. Privacy features. Security measures. Monitoring systems. 2. Implementation phase. Development practices. Code reviews. testing protocols, documentation, quality assurance, deployment preparation, system integration, user training, support setup, monitoring tools. 3. Operations phase, monitoring systems, performance tracking, issue detection, user feedback, impact assessment, maintenance procedures, regular updates, security patches, performance optimization, documentation updates. Closing. As we conclude our exploration of ethics in NLP, remember these key principles. Essential guidelines. Ethics first in development. Regular evaluation needed. Continuous improvement required. Stakeholder engagement crucial. Transparency maintains trust. Action items. 1. Conduct ethical assessments. 2. Implement bias detection. 3. Ensure privacy protection. 4. Monitor social impact. 5. Maintain accountability. Next episode, we'll explore advanced optimization techniques for NLP systems. Practice exercise. 1. Select an NLP application. 2. Identify ethical considerations. 3. Design mitigation strategies. 4. Plan implementation steps. 5. Define success metrics. I'm Muammar Lone. Remember, ethical AI is effective AI. See you next time.